Have you ever wondered what secrets lie at the edge of our universe? What mysteries could the early cosmos hold? Today, we're diving into an astonishing discovery made by the James Webb Space Telescope that has astronomers on the edge of their seats. This is a tale of cosmic proportions, an exploration of the unknown that stretches back to the dawn of time. Using the James Webb Space Telescope, or JWST, astronomers have observed an extraordinary cosmic dance, a supermassive black hole entangled with two satellite galaxies. This dramatic event, occurring less than 1 billion years after the Big Bang, provides crucial insights into the early universe and how galaxies and black holes evolved together. At the heart of this cosmic ballet is a quasar known as PJ 300-821. A quasar is a supermassive black hole voraciously consuming surrounding matter, shining so brightly that it outshines entire galaxies. JWST sees PJ 300-821 as it was when the universe was just an infant, thanks to its incredible infrared capabilities. Imagine looking back in time, over 12 billion years, to witness the birth and evolution of some of the universe's most powerful and enigmatic entities. But what exactly is happening in this cosmic spectacle? This particular supermassive black hole is feeding on surrounding matter and powering a bright quasar, a beacon of light from the distant universe. PJ 300-821 is localized to an active galactic nucleus, or AGN, in a galaxy that is in the process of merging with two massive satellite galaxies. The merger of these three galaxies is likely to deliver vast amounts of gas and dust to the supermassive black hole, facilitating its growth and allowing it to continue powering the quasar. Roberto De Carli, a leading researcher from Italy's National Institute for Astrophysics, describes this discovery as an emotional roller coaster. His team faced numerous challenges, but ultimately unveiled stunning details about the quasar and its galactic companions. Not only did the team determine that the black hole has a mass equivalent to 2 billion suns, but they also found that both the quasar and the galaxies involved in this merger are highly evolved. A surprise considering they existed when the 8 billion-year-old cosmos was just an infant. The data was collected in September 2022 by JWST's Near-Infrared Spectrograph, or NIR-SPEC, instrument as part of the 1554 program. This program aims to observe the merger between the galaxy hosting PJ 300-821 and two of its satellite galaxies. The work represented a real emotional roller coaster for the team, which developed innovative solutions to overcome the initial difficulties in data reduction and produce images with an uncertainty of less than 1% per pixel. Quasars are born when supermassive black holes with masses millions or billions of times that of the Sun sit at the heart of galaxies and are surrounded by a wealth of gas and dust. This matter forms a flattened cloud called an accretion disk that swirls around the black hole and gradually feeds it. The immense gravitational forces of the black hole generate powerful tidal forces in this accretion disk, heating the gas and dust to temperatures as great as 120,000 degrees Fahrenheit. This intense environment causes the accretion disk to emit light across the electromagnetic spectrum. This emission can often be brighter than the combined light of every star in the surrounding galaxy, making quasars like PJ 300-821 some of the brightest objects in the cosmos. While black holes themselves don't have characteristics that can be used to determine how evolved they are, their accretion disks, and thus quasars, do. In fact, galaxies can be aged in the same way. The early universe was filled with hydrogen, the lightest and simplest element, and a little helium. This formed the basis of the first stars and galaxies. During the life of these stellar bodies, they forged elements heavier than hydrogen and helium, which astronomers call metals. When these stars ended their lives in massive supernova explosions, these metals were dispersed throughout their galaxies and went on to be the building blocks of the next generation of stars. This process saw stars, and through them galaxies, becoming progressively metal-rich. The team found that, like most AGNs, the active heart of PJ 300-821 is metal-rich, and the gas and dust around it are being photoionized. This is the process by which particles of light, called photons, provide the energy that electrons need to escape atoms, creating electrically charged ions. One of the galaxies merging with the host galaxy PJ 30821 is also metal-rich, and its matter is also being partially photoionized by electromagnetic radiation from the quasar. Photoionization is also happening in the second satellite galaxy, but in that case, it is being caused by a bout of rapid star formation. This second galaxy also differs from the first and the AGN, as it appears to be metal-poor. Federica Loyacono, an astrophysicist from INAF, explains that thanks to JWST's precision, we can now study the gas properties near PJ 30821's black hole and its companion galaxies. This includes comparing the emission of hydrogen and other elements to understand the metal richness of these cosmic entities. Though light leaves this early universe quasar across the broad range of the electromagnetic spectrum, including optical light and X-rays, the only way to observe it is in infrared. That's because, as the light has traveled for over 12 billion years to reach JWST, the expansion of the universe has stretched its wavelengths considerably. That shifts the light in the direction of the red end of the electromagnetic spectrum, a phenomenon understandably called redshift, which is denoted as Z by astronomers. JWST is adept at seeing high redshift or high Z objects and events like PJ 30821 because of its sensitivity to infrared light. Thanks to the sensitivity of the JWST in the near and mid-infrared, it was possible to study the spectrum of the quasar and companion galaxies with unprecedented precision in the distant universe. Only the excellent view offered by JWST ensures these observations. Roberto De Carli and his team have shown us a glimpse into the chaotic and dynamic processes that govern the early universe. Their work reminds us of the incredible scale and complexity of the cosmos and our ongoing quest to understand it. So, what other mysteries will JWST unveil? How will these discoveries reshape our understanding of the cosmos? Let us know your thoughts in the comments below, and don't forget to like and subscribe for more incredible journeys into the unknown. To put it all into perspective, imagine standing on the edge of time itself, looking back to when the universe was just beginning to take shape. The James Webb Space Telescope, with its cutting-edge technology, allows us to do just that. By peering into the depths of space, it also peeks into the depths of time, uncovering the secrets of the universe's infancy. As the JWST continues its mission, we can only speculate on the many wonders it will reveal. Will it find the first stars and galaxies that formed after the Big Bang? Will it uncover new phenomena that challenge our understanding of physics and cosmology? Each new discovery not only answers some of our questions, but also raises new ones, keeping the spirit of exploration and curiosity alive. The journey to understand our universe is a collaborative effort, involving scientists and researchers from around the world. Each piece of data, each image captured by JWST, is a testament to the power of human ingenuity and our insatiable desire to explore the unknown. As we look up at the night sky, we are reminded that we are part of something much larger, a universe filled with mystery, beauty, and infinite possibilities. In closing, the story of PJ 30821 and its cosmic dance partners is more than just a tale of astronomical phenomena. It is a story of perseverance, innovation, and the relentless pursuit of knowledge. It is a reminder that even in the vastness of space, we can find connections, patterns, and stories that resonate with our own quest to understand our place in the universe. To dive even deeper, let's explore some of the intricate details of this discovery. Imagine the early universe, just a few 100 million years after the Big Bang. It's a time when the first stars and galaxies are forming from clouds of primordial gas. Among these young galaxies is PJ 30821, hosting a supermassive black hole at its center. This black hole, already 1 billion times the mass of our Sun, is a mystery in itself. How did it grow so massive so quickly? The JWST's observations suggest that the merger with the two satellite galaxies is key. These mergers bring vast amounts of gas and dust into the central region, feeding the black hole and allowing it to grow rapidly. This process also triggers intense star formation, lighting up the galaxies and making them some of the brightest objects in the universe. One of the most exciting aspects of this discovery is the detailed study of the chemical composition of these early galaxies. By analyzing the light from PJ 30821 and its companions, astronomers can determine the abundance of different elements, or metals. This gives us clues about the processes that were happening in the first billion years of the universe. For example, the presence of heavy elements like carbon and oxygen indicates that there were already several generations of stars that lived and died, enriching the interstellar medium with the products of nuclear fusion. But why is this important? Understanding the chemical evolution of galaxies helps us piece together the history of the universe. It tells us how the elements that make up planets, stars, and even life itself were formed and distributed throughout the cosmos. It's a cosmic detective story, with each new observation adding a piece to the puzzle. Let's talk more about the phenomenon of redshift. As the universe expands, the light from distant objects is stretched to longer, redder wavelengths. This effect is a crucial tool for astronomers, as it allows them to measure the distance and speed of faraway galaxies. In the case of PJ 30821, its light has been traveling for over 12 billion years, stretched into the infrared part of the spectrum by the time it reaches us. JWST's infrared instruments are perfectly suited to detect this light, providing a window into the distant past. The ability to study such high redshift objects is one of the JWST's greatest strengths. It can see farther and in more detail than any previous telescope, opening up new frontiers in our understanding of the universe. Each high redshift galaxy it observes is a glimpse into a time when the universe was young and evolving rapidly. Another fascinating aspect of PJ 30821 is its quasar. Quasars are incredibly bright and energetic, powered by the accretion of material onto supermassive black holes. The light from a quasar can outshine all the stars in its host galaxy, making it visible across vast distances. By studying quasars like PJ 30821, astronomers can learn about the conditions in the early universe and the processes that drive the growth of supermassive black holes. The accretion disk around a supermassive black hole is a turbulent and dynamic environment. As material spirals in, it heats up and emits radiation across the electromagnetic spectrum. This radiation can provide valuable information about the properties of the accretion disk and the black hole itself. For example, the temperature of the disk, the speed of the infalling material, and the presence of magnetic fields can all be inferred from the light emitted by the quasar. The discovery of PJ 30821 and its companions is a testament to the power of modern astronomy. It showcases the capabilities of the James Webb Space Telescope and the ingenuity of the scientists who designed and operate it. But it's also a reminder of how much we still have to learn. Each new discovery raises new questions and challenges our understanding of the universe. As we continue to explore the cosmos, we are constantly reminded of the beauty and complexity of the universe. From the smallest particles to the largest structures, everything is interconnected. The study of quasars and galaxies helps us understand not only the history of the universe, but also our own place in it. So, what does the future hold for the study of the early universe? With the JWST and other advanced telescopes, we are poised to make even more groundbreaking discoveries. We may find more ancient quasars, uncover the first stars and galaxies, and learn more about the mysterious dark matter and dark energy that make up most of the universe. Each new observation will bring us closer to understanding the origins and fate of the cosmos. In conclusion, the story of PJ 30821 is a remarkable journey into the distant past. It is a story of discovery, curiosity, and the relentless pursuit of knowledge. It reminds us of the power of human ingenuity and the incredible potential of modern science. As we look to the future, we can be sure that the James Webb Space Telescope will continue to inspire and amaze us with its discoveries. The universe is vast and full of wonders, and we are just beginning to explore its depths. Thank you for joining us on this journey through time and space. Stay curious, keep exploring, and never stop asking questions. The universe has many more secrets to reveal, and together, we will uncover them one by one. Until next time, keep looking up at the stars and dreaming of the possibilities.